Hey guys, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at lesson 2 from chapter 3, which is talking all about investigating quadratic functions in standard form. So the standard form of a quadratic function is f of x is equal to ax squared plus bx plus c, where a cannot equal 0. And so a, b, and c are just constants. So in an actual equation, those would actually represent numbers. So this is a different form of the vertex form equation. And so essentially in the next lesson, we will learn how to manipulate the equations, either both in vertex and standard form, and be able to change them to their opposite forms. So if you want just a quick example, maybe something in standard form, you can literally just replace a, b, and c with numbers, and that right there is a quadratic function in standard form. So say we had 2x squared minus 3x plus 1. That there is an example of a standard form quadratic function, and even say y is equal to 2x squared. That right there is a standard form quadratic function because here in our little statement here, a cannot equal 0, but that says nothing about b and c. So b and c here can be 0, just not a though. Because then what would happen if a was 0? Then that gets rid of this x squared term, making it no longer a quadratic function. So what we're going to do here is we're going to do example 2a from your notes. So a student council sells memberships for $6 per year and has 700 members. To increase revenue, they decide to increase the membership cost. The results of the survey indicates that 50 fewer students will buy a membership for every $1 increase in the membership. So what we need to do in this question is write a quadratic function in standard form to model this situation. So here we're going to write a quadratic function in standard form to model this situation. So let's go back and let's just kind of recap some of that important information. So we know that for right now, they're charging $6 per year and they have 700 members. They also know that there's going to be 50 fewer students buying a membership for every $1 that they increase the membership costs. So step number 1, whenever we're trying to create an equation given a word problem, is I would like to write the equation just using words and what we know about it. So we can start with, we're going to be looking for, say, your revenue. So here they're trying to increase the revenue, so we're going to find out what their revenue might be. And that's going to be equal to, so it's essentially going to be the price of their membership times the number of members that they have, and that'll tell you how much money they're making. So it'll be the price times the number of members. So then our next step is, well, let's actually set some variables here for some of our unknowns. So we don't know what our revenue is going to be. That's actually what we're going to be looking for, I guess, in this equation. So we can let R equal your revenue. And then say we're also talking about the price increase. So we can also let that be a variable as well. And you can say let that be P, let that be the price increase. If you guys would feel more comfortable, because I know in part B of this question in your notes would ask you to graph, you guys can also use X and Y. So in this case, your R would be Y, your P would be X. So from here, let's start by building that equation. So here in this equation, we don't know what our revenue is. That's essentially what we're trying to find when they're wanting to look at how much they're increasing their revenue by. So your revenue is just simply R, and that's equal to, so when we're talking about the price, we know that it was originally $6, but they want to increase it by, say, P number of dollars. So we could say that it was $6 plus however many dollars they increase it by. So we have 6 plus P. So that right there is that right there represents your price. Then we need to multiply that with the number of members. So with your number of members, you know that there was originally 700, and they're going to lose 50 for every $1 of increase. So we could say that there were 700 members, and it's going to decrease by 50 people for every for every dollar increased. So we have the basics of our equation right now, but now what we need to do is this has to be in standard form. So in order to solve this, we're going to use a method called distribution, or when we have a binomial times a binomial, we can use something called FOIL. So when we're using FOIL, it means that we're going to multiply the first term of each binomial. Then we're going to do outside. So outside, so be 6 times negative 50p. Then we do I for inside, so p times 700. And then last is p times negative 50p. So FOIL is first, outside, inside, last. So let's start. So we have 6 times 700. And then every time we do a new multiplication, we're going to separate that with a plus sign. Then we do outside, so 6 times negative 50p. Then we're going to do inside, so plus p times 700. And then the last terms, which is p times negative 50p. Then we can simplify each of these multiplications. So first off, we have 6 times 700. If you put that into your calculator, you should find that you will get 4,200. Then we have 6 times negative 50p. So putting that into your calculator, you should get negative 300 times p. Then you have 700p. And just remember to write your number out right out in front of that variable. That's just how we write numbers and variables in proper mathematic notation. And then we have p times negative 50p, which you would get negative 50p squared. So p times p is p squared. So then what we have to do is we are just going to regroup or collect some like terms just to kind of clean up this equation here. So we have 4,200. With this one here, there's no term that's in common because there's no other term here that does not contain any variables. So we move on to the negative 300p. So when you're looking for a common factor or something that is in common, you want to look for, say, something that has the exact same variable and the exact same exponent. So in this case here, we could combine negative 300p with 700p. Then we can also look at, say, negative 50p squared. That one there's nothing else that has a p squared, so we can leave it as it is. So let's write this. We have 4,200. And then when we're combining like terms, remember you just add or subtract your coefficients, but the variable stays the same. So you take negative 300 plus 700, which is positive 400, and then variable stays the same, so it's still p. Then we'll bring down this negative 50p squared. And then our last step here is just to reorder this, because remember in standard notation there, we usually go with our highest exponent going down to the lowest. So we're just going to reorder this. So we're going to write this negative 50p squared first. Then the next lowest exponent would be p, and this is say power to the power of 1. So plus 400p. And then plus 4,200. So if it's, say, the first term, if this is just a positive value, just separate it with a plus sign. And when I'm asking you to just give the quadratic function to model the situation, you don't need to write a sentence for this, or say when you're graphing. But say if I were to ask you to find some actual values, I would definitely be asking you to write a sentence there, okay? So that concludes part A of this example. So if you guys have any questions, just come see me in class or text me on Remind 101. And thank you guys so much for watching.